finding a normal probability between two values. So far, what we have done is finding the probability, for example, that x is less than x0, x0 is any value, or we find actually the probability that x is greater than x0, x0 any value. What if actually we want to find the probability that x is between two values? For example, the probability that x is between x1 and x2 for any values of x1 and x2. What should we do with this? So here we want to see what should we do. Suppose x is a normal probability distribution with an average of 8 and a standard deviation of 5. We want to find the probability that x is between 8 and 8.6. What should we do? So let's actually graph this distribution. This is the graph. The probability that we are looking for, the probability that x is between 8 and 8.6 actually is the red shaded area here. So what we need to find is the red shaded area here. But how we can find that? We learn how to find the probability that x is less than a value or a shaded area on left or right, but not in between. So if you look at it closely, you can actually turn this into two different shapes, this shape and this shape. So I'm going to call this area 1 and I'm going to call this area 2. This is the area, the first A1 is the area that x is less than 8.6 and A2 is the area that x is less than 8. What we are looking for here, the area between 8 and 8.6 is actually the subtraction of A2 minus A1. So if we find A2 and A1 and then subtract A2 from A1, we're going to get what we are looking for on the right. Okay, so let's do that. Probability that x, this is equal to the probability that x is less than 8.6 minus the probability that x is less than 8. So we find these separately. What would be this value? We're going to convert this to the z distribution. So that would be the probability that z is less than the z value of 8.6, z value of 8.6 minus the probability of z less than z value of 8. Okay. What is z value of 8? Z value of 8.6. Z value of 8.6 is 8.6 minus the average, which is 8, divided by the standard deviation, which is 5. So we find this z value, which is actually it's 0.6 divided by 5, which is 0.12. And the z value of 8 is actually 0 because it would be 8 minus 8. So what we need to do is find the probability that z is less than 0.12 and z is less than 0. And if you find it from the z distribution or using the Excel function, that would be 0.047. So the probability that x is between 8 and 8.6 is 0.047. So that's it. This is what you need to find the probability, how you can actually find the probability that x is between two values. You need to find the probability that x is less than the greater value minus the probability that x is less than the smaller value. Here is greater value 8.6 and a smaller value is 8. So that would be the probability of x is less than 8.6 minus the probability that x is less than 8. The inverse function, given a normal probability finding x. So we want to find a list of the steps of finding x giving the probability. So we have a normal probability, x follows a normal distribution, the average of mu and a standard deviation of sigma. What we want to find is we want to find x such that its probability is equal to the given probability that we have, say alpha. So assume that we know the probability, which is alpha. We want to find x here. What are the steps to do that? Okay, the first step, we need to find z of x for the known probability of alpha. So what we need to do is to find the probability for to find actually z of x for the alpha probability for z distribution. So we convert this to the z distribution. We'll be looking for z of x such that its probability is alpha. So we look for z of x in the z distribution as we did it for the previous problem. After finding z of x, we can follow the next step. The next step is to convert to x. So we have z of x, we found it from the table, and we convert z of x to x using this formula. X is equal to mu plus z of x, which we found it from here, multiplied by sigma. So not very difficult, very actually easy. All right, so we learned two problems for normal distribution. The first problem was if you have the z value, z of x, you find the probability. So we know the z of x, and we want to find this probability, alpha. Right? We can use the z table to do that, right? Or we could use this formula from Excel to do that, norm.s.distribution z. So in this problem, we know x or z of x, and we are looking for alpha. So that's the first problem that we learned. The problem that we learned in this lecture is we know alpha, we are looking for x or z. So that's the second problem. If the probability of alpha is known, we are looking for z of x or x. So we can use the z distribution table as we did it before, the step that we mentioned before, or we can actually use the Excel to do that. The Excel function is norm.s.inv of alpha. Or you can actually use the for general problem, not for a standard normal distribution, just for a general normal distribution. And that would be x is equal to norm dot inv. And then you would give it the probability, alpha here, and the average, and the standard deviation. And it would find for you the alpha. Let's see an example. Let x be the time that it would take in seconds to download an image file from the internet. Suppose x is normally distributed with an average of 8 seconds and a standard deviation of 5 seconds. Find x such that 20% of download times are less than x. So this is an inverse problem or type 2 problem. So we have a normal distribution, x is representing the download time. It's normally distributed with an average of 8 seconds and a standard deviation of 5 seconds. We are looking for value x such that the probability that the download time is less than that is equal to 20%. What is x? We are looking for this x. So this is an inverse function problem. So we're going to go with the steps that we learned to do. The steps is first we need to find z of x. So we assume that we know the probability. So that's the probability of z less than z of x is 20%. We find z of x, and then we're going to use the formula, which is x is equal to mu plus z of x multiplied by sigma. After finding z of x, we plug in this formula and we find x. So we know the probability, that's the shaded area here, which is 20%, and we are looking for X, or Z for that matter. Okay, so if you look at for the table, you find the Z of X to be negative 0.84. And given that we know the Z of X, we're going to plug it in this formula and we're going to find X. So X is 3.8. So for 3.8, the probability that X is less than 3.8 is actually 20%. So we find X here.